Okay, question number 2 from the 1.6 lesson. Okay, it says that a soccer ball is kicked from ground level. When it has traveled 35 meters horizontally, it reaches a maximum height of 25 meters. The soccer ball lands on the ground 70 meters from where it was kicked. The first question asks us, model this situation with a relation in the form of y equals a times x minus h squared plus k. So we want to put it into vertex form. This is the vertex form, which means we need the vertex. So we need the vertex, which is our h and our k value. It tells us in the question that when it has traveled 35 meters horizontally, it reaches its maximum height of 25 meters. So we know that this is going to be our vertex. So our vertex is, so it says horizontally 35 meters. So horizontal is always our x value, or in this case h. So our vertex is going to be 35, 25. So it reaches its maximum height of 25 meters. So we want to put it in this equation. So we can put our vertex in. So x minus 35 squared plus 25. Now we don't have our complete vertex form yet because we're missing our a value. We need to find our a value. So need to find a value. To find the a value, we need another point to plug in for x and y, and then that way we're only solving for our a value. So find a point x, y. In our question, it gives us another piece of information. It says the soccer ball lands on the ground 70 meters from where it was kicked. So the 70 meters is our horizontal distance, which that means it's our x value. And from here we can find out what our y value is. It says the soccer ball lands on the ground. If it lands on the ground, it has not moved up vertically. So that means it has a vertical height of 0. So that's our other point. So 70 meters from where it was kicked, it is on the ground. So it's a height of 0. From here we can plug this into our equation. So our y value that we have is 0. We are looking for our a value. So our a value is still a. And we can plug 70 in for x. So now all we have to do is solve for this a value. So 70 minus 35 is 35, so 35 squared plus 25. 35 squared is 1,225 plus our 25. Let's move our plus 25 over to the other side, so it becomes minus 25 is equal to 1,225a. We'll solve for a by dividing 1225 to the other side. And we can simplify that. If you divide the top and the bottom both by 25, you will get your a value. So let me see here. I don't have too much room. I'll put it here. So a is equal to -1/49. Okay, so from here we have our a value. So now we can write our relation. So our a value is -1/49. X minus, we have our vertex of 35 and 25, so plus 25. So this is the relation that models the question number 2. Okay, so from here we can move on to question B. Okay, so from question B it says, what is the soccer ball's height when it is 50 meters from where it was kicked? Okay, so first of all, we're going to need that same equation that we just found, so I'm going to write that down. This is our equation that helps us answer all other questions. Okay, so what is the soccer ball's height when it is 50 meters from where it was kicked? So if we're doing that, 50 meters from where it was kicked, that means that that is our horizontal distance. So we want to find y when x is equal to 50 meters. So we are looking for our y value, what is the height when the horizontal distance is 50 meters. So from here we just need to sub x 50 into x and solve for y. Sub x equals to 50, solve for y. So we go to our equation and we sub that in. So our x value is 50, so 50 minus the 35 squared plus 25, and here we're just solving for y. So 50 minus 35 is 15 squared plus 25. Okay, so y is equal to 1 over 49. 15 squared is equal to 225. 25. I'll move my equation up here. So we have negative 225 for 49 plus 25. I'm going to divide 225 by 49, and that gives us negative 4.59 plus 25. And that gives us 20.41. So that means that the ball's height when it is 50 meters is 20.41 meters. Therefore, the height is 20.41 meters when x is equal to 50 meters.